this is the analytical chemistry of the electrolytic process. The process analysis is based upon what we call Faraday's law. Which simply states that the amount of electric charge needed to provide 1 mole of electrons is called 1 Faraday. All right, having said that, what I'm trying to tell you is 1 Faraday, capital F, if you will, is equal to 96,500, trust me on this, amp seconds. Trust me on this. This is a big conversion factor. And this is 96,500 coulombs, which is equal to 1 mole electrons. All right. This is nothing more than a very big conversion factor, and you use in working electrolysis problems. Okay. Question like this: how much copper solid can be deposited in electroplating using a current of 40 amps for 48 hours. Now what this essentially means is that the device you want to coat or plate is one of the electrodes. You'll have a negative and a positive electrode hooked to some big battery, and so you want to copper plate it, whatever. You stick it, you connect it up to as one of the electrodes, and it happens to be the reduction electrode. Okay, that'll be the cathode. So if you want to electroplate a spoon, and you want to hook it up to the negative electrode, so the copper will be attracted to it. Okay. Now that's basically what you're doing, and they have these big vats and large power sources, transformers and things, and they electroplate everything from chrome bumpers to silver plating and so forth. It works just like the theory works. Okay, work these like you would work any conversion problem. What's the question, and then where you're going. Okay, what's the question? Here it is. How much copper solid, now I'm going to put grams in here because that's what your grams of reduced form equals a piece of data that's in the problem. Now you can use the time or the current. I like to use the current because I can go right into the conversion factor. So I'm going to use 40 amps, like that. Again, question and piece of data. You can work with the time and it will work, but I like to work with amps because it jumps right into the Faraday ratio. Okay, so in this, I'm going to be, let me say this. Maybe we're using copper sulfate as the salt. Okay, so 1 copper in that. So this is going to be copper plus 2 plus sulfate minus 2. You're going to be reducing copper. 2. How many electrons do you need to get a reduced copper? 2 electrons. 2 moles of electrons. So that's going to be 2 Faradays. Watch how that pops out. Okay, so I got 40 amps. Now I got to get rid of amps, and I'm going to grams. Okay, when you look at the conversion, here's one that's got amps in it. So what I do is time sign line 96,500 amp seconds. Now, what will that deliver? That will deliver 1 mole of electrons. That is a given. That's a Faraday. Now, you're not quite to your grams yet, so you want to continue. All you've done is canceled your amps out. So you're really at moles per second is what the issue is. So now you want to get rid of moles of electrons. Well, the idea is 2 moles of electrons will produce 1 mole of copper metal. Because look up here. We need to reduce that to the metal. I've got to have 2 electrons per copper. That means I've got to have 2 Faradays, or 2 moles of electrons for 1 mole of copper. Okay, I've gotten rid of moles of electrons. Now I've got moles of copper over moles of copper per second now. So I need to convert that to grams. So I need 1 mole of copper, grams of copper, 64. So I have 64 grams of copper per mole. Now my moles are gone, so I cancel that out. So I've got grams per second. Okay, I'm looking at 48 hours. And this setup right here will tell me how many grams I get a second. So what I want to do is integrate this 48 hours into my conversion sequence right now. So to get to hours, I'm at seconds right now. I need to get rid of that. So I need seconds and hours. They're 3,600 seconds. I need that on top. Sorry. Seconds, hours, 3,600 seconds per 1 hour. So my seconds will drop out. So now I have grams of copper per hour. Now, so how many hours I got to take this into account? 48 hours. So I cancel my hours out, and so now I have the entire conversion set up as to how much in grams I will need. So this then changes to 40 times 1 times 1 times 64 times 3,600 times 48. So that takes care of all the numerators. Come down here, go along 96,500 right there. I need 2 right there, and everything else is a 1. This would be grams of copper deposited in 48 hours. So your conversion canceled out everything except grams, and then you had grams per hour, then times 48 hours. Like that. So punching this into the calculator. So I've got, in my calculation, 2292 grams of copper deposited from the copper sulfate using 40 amps for 48 hours. Now you could have it set up where it would just build up a big block, and then you sell it off in a big block. Okay. Another kind of problem that pops up is how long does it take? Okay, so how long will it take, so to speak, and time, however you want to express the time, to deposit some of this. take to deposit 500 pounds of silver from a silver nitrate aqueous solution using a current of, I don't know, 50 amps. Just making them up as I go along. So you can express this in any format you want, seconds, nanoseconds, hours, year, day, whatever. But you want to get it into some time form. Well, what in our conversion factor has time in it? Well, the 96,500 amp seconds has time in it. So we're going to use that as soon as we can. Okay. What did I tell you? Just how do you start? You start with a question. What are you looking for? How long? Now, how you express this, you can any way you want. We can start with how many seconds. Okay. Now, I like to start with amperage as the data point to start with, because it jumps me right into the Faraday's law. And so here's 50 amps. Now I want to get rid of amps and go to whatever time thing I want to go to. How long will it take to deposit this 500 pounds of silver? Well, that's going to be one of the conversion issues also. So how do I get rid of amps? I have to have amps in the denominator in the next term. So 96,500 amp seconds. So I got rid of my amps. Now I'm at moles electrons. So that accounts for 1 mole of electrons. Now I've got to reduce my silver. How many moles of electrons to reduce 1 mole of silver? Well, silver is a +1. Okay? Because silver nitrate, that gives you a silver and a nitrate ion, like that. So it's going to take 1 mole electron for 1 mole of silver metal. Now, how much have I got to reduce? 500 pounds of the stuff. Well, typically this is not in terms of pounds, so I got 1 mole silver. It has a weight of 108 grams of silver. So my moles of silver are now taken care of. Moles of electrons are gone. Now I need to convert grams to pounds or so forth. So I have grams of silver. That's 454 grams is 1 pound of silver. I got that off the conversion. 1 pound is 454 grams. So now, get rid of. Now I'm in pounds of silver per seconds. Okay? So now I want to work this out. So I have 50 times 108 divided by 96,500 divided again by 454 pounds per second if you want to go that way. Okay? Which gives me, let's get that one worked out. 50 times 108 divided by 96,500 equals, divided by 454 equals, okay, so I'm going to put that in exponential. So give me 1.23 times 10 to the minus 4 pound per second. Okay, now I need to take this and my 500 pounds and mathematically combine them so that I wind up with seconds. What do? I'm looking for seconds. So how many seconds I will divide into 500 pounds this 1.23 times 10 to the minus 4 pounds per second. Invert and multiply through by the units. The pounds will drop out, and this will tell you the number of seconds. See how I chose that? I chose it so that the time frame would come out right. 500 divided, you couldn't do it, you couldn't get a time any other way. 500 divided by 1.23 times 10 to the minus 4. So I have second. So I have probably 1 times 10 to the 6 seconds to give me 500 pounds of silver metal. Okay, well that doesn't mean anything, so let's put it into hours. Okay, so I want to divide that by 3,600 seconds per hour. So that's roughly 1,130 hours. Okay, and 24 hours in a day, so when I divide that by 24, and so that's 47 days. And so that's about a month and a half. Okay, running it like that. You wait that long? No. Yes, sir.
It's 4.1 times 10 to the negative 6.
All right, let me stop this show here for a second.